Okay, so hello everyone again. Now I will present seventh place solution, and I'll move to quick introduction of our team. So our team consists of two members. I am Taras Semenchenko. I'm machine learning engineer at the software company, and also I'm master degree student in software engineering in Taras Shevchenko National University of Kyiv. And the second member is Andrei Ivanenko. He's also student, master degree student in software engineering at Shevchenko National University. And actually, we are both from the same university. We are friends, and it was one of the reasons why we decided to team up. Yeah. Also, we had tried to participate in previous competitions, but actually, it was our first active competition, and in fact, it was our first medal that we got. So, and we're really excited to show you. Okay, about our summary of our solution. Our solution was built on, was based on min prompt. So, and it was involved min prompt training, generation of training dataset, combination of our min prompt and LLM prompt. And the whole training process took up to 10 hours. And we were using RTX 4090. Okay, so, and at first, I would like to start from the training methods. The training of min prompt. So at first, we found dataset with a lot of different prompts, and if I'm not mistaken, it contains about 8,000 of different examples. And we found that we can create min prompts that will be similar to all these examples in our training dataset. So, and to do so, we used a couple of different methods, but the best one was beam search. So the method just adds one word at a time to the end of min prompt during each iteration, and each this additional word increases similarity of our prompt to the whole training dataset. To train it, we started with basic initial prompt revises text that had pretty good performance on the leaderboard. It is very short, so we started from it, and we were looking for the best next prompt to enhance its performance. Yeah, and it was the first method, and after a couple of days, we found additional two methods, and the second one is word insertion. So this method just inserts words into all possible spots of the prompt in case when it improves its score. So instead of adding to the end, we just insert to the different spots, and actually it is a greedy algorithm that just finds the best word. And also, I would like to highlight that we were using words from constructing our min prompt. We didn't use tokens as previous participants. We did it because when we tried to use tokens, our min prompt had overfitting problem, and using only words leads us to better performance on the leaderboard. So, yeah, and the third method that we found is prompt trimming. We found that when we constructed our prompt, we can also additionally remove some words from it, and it also can improve its score and similarity to all our training set. And the whole our algorithm was as the following. We started to train our min prompt from the word revises text, and then we applied beam search with width of 5, and we generated additional words to make it approximately 100 words in total. Yeah, and actually we tried also larger width parameter, but we found that 5 is the most optimal because when we use a width of 50, for example, the next method will not work because words in our min prompt will be tightly wired together, if I can say so. Yeah, and after Beam search, we are applied insertion and deletion operation, and we did it sequentially. So we just insert in spot some words that can increase similarity to our training data set, and then we apply trimming because it also can improve it performance. And at the end of each epoch, we just applied additional trimming to make our prompt 122 tokens or less. And I'll explain why we did it later. And the whole process of this training, we can imagine just like optimization of this prompt, just like gradient descent or similar. Yeah, and I think we train our min prompts that we created algorithms that can train min prompt very close to the best possible min prompt in our training dataset. Yeah, actually, using these three approaches, we could reach to 0.68 score on the public leaderboard. But later we found, as we train our prompt longer, the score on the leaderboard was getting worse and worse. And that's why we decided to regenerate our dataset, because it was very biased, and we just wanted to make it as close to the leaderboard as it possible. Yeah, and before moving to the next slide, I just wanted to explain the main idea of this dataset generation. The first thing that we did, we found all public available prompts, and we constructed a huge dataset of these prompts. And then we just need to, from these prompts, we just needed to create new dataset that will, if we evaluate our previously submitted min prompts on this new our dataset, this evaluation should show similar results to the leaderboard. And it was the main idea. So to do so, we created our prompt base that was consist of all our min prompts that we previously submitted to the leaderboard. It contained our min prompts and also scores of these prompts on the leaderboard, as you can see on the slide. Yeah, and then to start generating new dataset, we just needed to define an evaluation metric that can show how similar our generated dataset to the leaderboard. And to define this metric, we did the following. We evaluated all our min prompts from our min prompt based on our local dataset. We get their scores, and then we compare our scores from our local dataset with the leaderboard ones. And for comparison, we used cosine similarity metric. And the result, it is the value that shows how similar our dataset to the leaderboard. Yeah, and actually, to generate our new dataset, this process is similar to the generating prompt. We just train our training dataset. And to do so, we just took 10. We just took sample of 10 random prompts in each iteration, and we added it to our new dataset if it improves our evaluation metric. So, and we did this process until we achieve a desired score of this dataset. Yeah, and applying this this approach, we could reach the score of our min prompt up to 0.7, and it on the public leaderboard, and it was min prompt only, without any LLM. Yeah, but later we found that we just can't improve our min prompt further. Sorry. And we found that we can combine our main prompt with LLM inference. And to do so, we just used Mistral with 7 billion parameters. It was original Mistral without any fine-tuning. And we make it to generate prompts starting with the prefix improve this text by. And we just took the part the part that LLM generated, as you can see on the slide. And as you can see, we just combined our main prompt with LLM prompt. Yeah, but here we had some restriction. When our prompts exceed 128 tokens, for some reason, leaderboard score became very bad. And to do so, and to make it work as we wanted, we just need to trim our final prompt up to make it not exceed 128 tokens. Yeah, and it was one of the reasons why after each training epoch we trimmed our prompt up to 122 tokens, because we just we will not use the whole main prompt. We also will add LLM prompt. So, and this trick, with this trick, we improved the score by 0.5%. Actually, it's not too much, but it's also was an improvement. Yeah, and about our interesting findings. So we found it was the main findings that we got. It is possible that to construct necessary sentence embedding of the 5-sentence model by adding words to its input. This is the first one, and the second is combining min prompt with LLM prediction can also improve similarity score. And the third is that if prompt was longer than 128 tokens, that it will have a poor score on the leaderboard. Yeah, and I think that's all. That was all our solution. Thanks for your attention, and if you have some question, we are ready to answer them.